Assalamu alaikum wa rahmatullah. Welcome to the second part of our lecture 5. Here we will do one more example. We will start with one more example. So uh, we have a cylindrical, surface here, is given surface here, and the question has been asked that to calculate the distance of BC, the distance of CD, BC, distance of BC means from B to C. The distance of CD means from C to D. The surface area of ABCD. The surface area of ABCD means A, B, C, D. No problem. The surface area of ABO. The surface area of ABO means this area. This only. Okay. And the volume. Okay. The surface area of AOFD. Let's see what is it. So A O F D. Okay, no problem. And then the volume means the whole volume. Okay. So we will learn how to do. Actually, we have done it in our previous solutions. We already use that to learn about length. If we try to calculate length, we do one integration. To find the solution of the surface means area, we need to do double integration, and to find the volume we need to do a triple integration. So we will do the same thing, but here it's a good thing that our surface is given already, that this is a cylindrical surface. Okay, so all the cylindrical measurements we will take it here. Now we go for the solution. Let's say first the distance. What is the distance? The distance between B and C. So B and C. Now look, concentrate what I'm telling you. In this length, which one is variable? Check here, coordinates. Z, A, X is not variable. There is no variable rather than Z, right? Because only the Z is changing here. So we can see dz only. So in the cylindrical coordinate system, the dl becomes dz. So we will integrate only the integration to find the surface, find the length of this one is L is equal to integration of dz from what is the limit? The limit from 0 to 10 here. So the BC is dl is equal to dz, right? So hence we got BC is equal to integration of dl, which is dz from 0 to 10 means 10. So we get the distance of this two is 10. Now we go for the distance of CD. CD, what is this variable? There is no Z element here. There is no rho element here because rho is constant throughout this one. So the phi is moving. It means we need to find phi, right? But we know from if we have x, y, and z, we can find easily phi, right? So let's see. Not phi, of course not phi. It's rho we need to find, but the phi we will integrate. So, but to find out this length of this this arc, we need to always multiply a rho with phi always, right? So our differential of CD, differential length of our CD becomes rho d phi, which is rho d phi. Now we need to find what is rho. Rho is 5. How? Well, I will not tell you that how to find rho, because you know already, if the given coordinates are there, if the coordinates are there, then you can convert it to rho. So just convert it to rho. Okay, as far as I know that the rho is this length, right? This length, right? So your rho is, remember this one, rho, this is phi, and this is z, right? So z, and this is rho. Okay, so your rho is 5. Your rho is 5 here. Okay, there is no rho here because this is y on the y, so there is no rho here. So this is rho and this is phi. So I ask you to find it. You have problem, then you can tell me. But from here we can find out that our rho is 5. So we know rho 5. So 5 rho is 5. So rho goes out. And here, let us see what is this. This is 90 degree, right? Between x and y, right? So the phi have a limit of pi by 2. So from 0 to pi by 2. Look, you need to find these things. Okay. Phi. How you can find phi? I have teach you already in the previous classes. Okay. So from phi, there are two different phi you can find. You will find from here until here. You will find for this you need to find phi 1, and from here you need to find phi 2, which will give you the limit from 0 to pi by 2, and then you integrate, then you will get 2.5 pi or whatever, if you can put it in other way also. I'm gonna go a little fast because these things actually known to you. So now we go for we deal with 2 already. So now C, let's say ABCD surface area. So ABCD surface area. So there is, which one is constant here? Only the R constant, because this phi is moving and Z is moving, right? So we have phi, rho d phi dz here. So rho d phi dz, and the limits are there. So we find this one. Now area of ABO. Area of ABO. So A, B and O. So we move phi and rho, right? Z, no Z here. So phi means rho d phi, and rho d rho. So d rho and rho d phi here. So rho d phi and d phi and the rho here. So rho d rho will stay and d phi will separate. So d phi and d rho, you know it. So that's how we get it. Now AOFD. We need to find out AOFD. AOFD. Which one? So only we find the rho is moving and the Z is moving. So there is no phi element. So dz and d rho here. So we find out d rho and dz. We get 50. And the volume, as simple as that, we multiply rho d phi dz and d rho. So that's how we get these values. It's up to you to practice it properly. This is the examples here. If you find any problem and difficulties, you get back to me. No problem. We move on to our another topic, which is del operator. So in our whole classes of electromagnetics, we will always find this del operator, which actually signifies, if we expand it, it's like plus minus. If you put a minus sign somewhere, it will deduct, right? If you put some divide sign, it will try to divide something. So similarly, if you put del operator, it will do this operation. What is it? It will partial derivate your vector. Okay. So del operator, if you multiply with this one, it will just partially derivate your vector. So we will go for an example later on, and then we will see. So if, let's say, your vector is A is equal to AX plus AY plus AZ, if you multiply with this one, so this will become, it will take the vector along A direction and then differentiate this one. This one, the partially differentiate along Y direction and Z direction, this will do. So if you multiply this one, the del operator, with any vector, it becomes the gradient. Okay. So to find any gradient, you just multiply the del operator with any given vector. Similarly, to find divergence, you need to do a dot operation with this del vector and your given vector. And we know also, we already learned about the cross operation, right? So we do any cross operation we do with the delta operator with any vector becomes the curl. And then this one I will not teach actually. because this I don't think that you need it. But this one is, you made a double integrate differentiation of any vector becomes Laplacian, the Laplacian of scalar. If you really want to know this, I can obviously give you a lecture on this one, but my recommendation is you don't need to learn. So we move on to the problems actually, the demonstration, how it can be done. So let's try to go for the Cartesian coordinate systems. So gradient, we're talking about the gradient of a scalar. So the gradient, let's say we have a v vector, so we just multiply with this one. So ax, ay, and az will be there, right? But for cylindrical, it will change. It will become d rho, right? The x will be replaced by rho, and then y will be replaced by rho d phi, and z will be replaced by z. It's similar, right? But this, you need to remember this one. Don't need to remember. I didn't put any derivation because the derivation you don't need to learn. Okay, this is for the research students, not for you. So don't worry. These formulas will be given in the exam. Don't worry. Okay. So this you need to remember, and this, once we go to solve any problem, we will learn how to do it. So for cylindrical, this is like this, and then for spherical, r d theta and r sine theta d phi. We already learned about it. So we need to follow this one. So if somebody's asked find the gradient of a scalar, means you need to find Cartesian, cylindrical, or spherical. Okay. If it's given in spherical, you do in spherical. If it's given in cylindrical, you do in cylindrical. If it's given in Cartesian, you do it Cartesian. But however, to detect this one is Cartesian or cylindrical or spherical, it's up to you, because I teach you already how to find out. So we go for a for a solution now, a problem, an example. Given that find the gradient of the following scalar fields. So V is given. Okay. So we need to find the gradient of these three. So let's talk about V first. V is, this is e to the power minus z sine twice x cos hyperbolic y, right? What is this coordinate? This coordinate consists z. It means it can be, it is not for sure spherical. Either it can be cylindrical or either it can be either it can be cylindrical or Cartesian or the rectangular, right? But there is no phi here or rho, so it is rectangular or Cartesian. So we know it, so we go for the solution. So gradient, right? So you multiply del operator. This one we will choose. So here. So we put this value here, V. So we check here, put here. We replace V here, and again V, the same V here, and then V. So the V will be always here. So we put e to the power minus z sine twice x cos theta here. The same thing we put here, and the same thing we put here, and then we derive. Okay. Now when we derive the partial derivation, only x related things will stay. Rest will go out. So if you differentiate, partial differentiate dx, means not dx, actually this is small delta x. So here let's talk about this one here. So you are differentiating this one with corresponding to this one. So this have z, right? So it will go out. This will stay and this will go out. So this will only differentiate the sine twice x, which means 2 cos twice x. So which is 2 cos twice x. So z and this cos, the e to the power z minus z and cos hyperbolic y is the same. Similarly, you do this one, you will get this, where y element will stay and the rest will go out. So this 2 is not y, doesn't have any y element. So these are 2 will be considered as a constant here for this one. So Ez and sine twice x will be outside, and cos hyperbolic y will be sine hyperbolic y if you differentiate this one, and y will stay, and so on. So this is how you will do it, and then similarly this and this will be done by you. It's up to you how you do it. I will not I will not demonstrate it here. Okay, we'll do maybe in the tutorials. You can ask me more questions about it, or if you cannot do it, I will demonstrate you on hand, inshallah. So, but I want you to do it, since these differentiations, integrations, and this should be already, you should have already learned in your engineering mathematics, calculus, and other mathematics courses. So this is how you put it here. Similarly, you use this for this, because this is rho, z, and phi. So it's we already know this is cylindrical, and this is already spherical, because r, theta, and cos. So you, for this, you use this. So now this is done. So we move on to our divergence. Divergence is simpler than this one. Divergence is you do dot. Okay. So a element, let's say a vector is given, then you use this x element of a vector to x, y element of that a vector to y, and z element of this a vector to z, and you use this equation. And for cylindrical you use this equation, and spherical you use this. But we go for a solution first, and then we will learn it. So let's say P is given. This is the vector given, a vector which have ax, x square yz, ax plus xy az, and we need to find a divergence. So we use this equations and see what happens. So this one, we put it here. So px, which is this, px means what? This one, right? So x square y z. So here we put x square y z. Now del y is py, right? Because it's p, so py, but there is no py, because there is no y direction, any component which is representing y direction, so we don't take any, so it's 0. And then the z is here. Just differentiate this one. If you differentiate, then x will stay, y and z will come out, so 2x, so 2x yz, 2x yz, and here the z will stay and x will come out and become 1, so y only. So like this. So similarly for q, you use this formula, and then you use the same and you get this one. And for t, the same. I went a little bit fast because these are the calculations which have to be done by you and you. If you cannot, you have to do it fast at the first place. If you cannot do it, if you find difficulties, then I am here. I'm always here in online during fun around 9 to 5, or if you can stretch up till 6 o'clock, no problem. And if somebody wants to talk with me around 7 o'clock, even, no problem. Okay, so I will be online, and I will show you how to do it step by step, inshallah. So, but curl, for curl, I will demonstrate I will give you the equations only. I will not do any examples, but later on I will put up some examples, problems that you practice by yourself. So for curl, in 3 different coordinate system, these are the following equations you need to follow. Now this is your attendance assignment lecture for lecture 5. So determine gradient for this. Okay, you need to determine your gradient for this, and you need to determine your divergence for this. I didn't give you any curve. So I will put by tomorrow, I will open a portal today. By tomorrow you need to submit your your attendance. Okay. So I hope that you understand everything. You understood properly everything clearly. If not, then I'm here. I will help you to solve it. So, but until that time, this is all. And in our next class, we'll directly move on to our electrical field, or which is called it Coulomb's law. So we'll move on to another chapter, which is corresponding to electrostatic. So from there, we will start with the electrical Coulomb's law of electrical charges. So I'm signing myself off. Assalamu alaikum wa rahmatullah. See you in the next lecture, inshallah.